Ladies and gentlemen, this is Mr. Green, and this is another in my recordings for AP Statistics. Just where are we at? Well, I'm going to be doing lesson 6.3, study number 1, and that's where we're at right now in the course. I realize, well, where it says we're doing Unit 6, it's just a continuation from last semester. This is the precursor to inferential statistics. You got to make certain you understand this stuff before we get into it. And this is geometric distributions. So we're looking at sampling distributions and sampling distributions of a sample mean and the central limit theory. But the first one is geometric distributions. Things you have to check. You have to check to see that it is independent. You have to see that it is the probability of, there's a P, probability of success for every single outcome of a particular situation. That X is the number of trials required to get the first success. It could be infinity. I mean, you could go forever and never get a success. I mean, how many of us have ever played the McDonald's game at the Monopoly game at McDonald's and never won anything at all? I mean, you might win a French fry here and there or an apple pie, but you never really win anything at all, right? But X is a discrete variable. I mean, it is discrete in the sense of it is a set number of trials, 1, 2, 3, 4, number of times going to McDonald's and eating their Big Mac, things like that. Now, in this particular thing, when you look at it on a graph, on a geometric distribution, what you'll see in a histogram is it is really high on this end, and as it goes down, it goes way down like this. It's skewed way off and almost approaches zero as it gets down out here to the right. That's what we mean by saying it's severely skewed. Okay? It's nowhere near a normal distribution, so don't get this confused. So when we're looking at geometric distributions, there's a probability of getting it on the nth trial, and that can be done on the calculator in a GEOMO. I can't even say it right. GEOMEP or MET, geometric, and then a PDF. PDF meaning the probability distribution function. Okay, and you're finding the area underneath the curve. Actually, if you calculate it, it's the probability of X equaling N. The way calculator of X equaling N. And so you've got 1 minus the probability of each outcome raised to the n minus 1 power times the probability of an outcome being successful. Or you could have the probability of getting it on or before the nth trial. It's the sum of all the probabilities up to that point. Or you can do a CDF, which is a cumulative probability distribution on a function. And you're just summing up all of these probabilities that we've got up here. Okay? And this, you can do it on the calculator pretty quickly with that CDF. So let's look at some problems here. Oh, one more thing, average wait time. This one is the easy one. So if you've got a probability of an outcome being being P, of a success being P, then the average wait time is going to be 1 over P. And that's the easy one to figure out. Okay? And that should have shown up there. I'm sorry. Won't worry about those. So what is the probability that the firstborn son is the fourth child? What is the probability of this occurring at any time? That P is going to be equal to 0.5. Why? Because half the time it's male, half the time it's female. That's the probability of each individual occurrence. So they're saying, what's the probability of the fourth time? So they're saying it's P X equals 4. And that's what we're going to do. We're going to figure this one out, okay? So we're going to take, let's see here, 0.5 raised to the fourth power, raised to the third power, times 0.5, right? That's our formula that we've got that we can use. Backing up here and showing it to you. Right here. Raised to the fourth power times P. That's what we would use right there, okay? So how do we do this? On the calculator. We go second distribution, and we're going to do a geometric PDF. That's number E there. So I'm going to go up there to number E, and I'm going to press enter. It's asking me how many, what's the probability of each individual outcome. That's going to be that 0.5. And they're asking me how many times are we going to try it? Well, we're going to try it 4 times. And the probability of this, when you work this out, is 0.0625. Which is equal to 6.25%. It's 25%. Okay? So what's the probability that the firstborn son is at that the first son born is at most the 4th child? Well, when you look at this is the probability of x at most. Okay? So that would be less than or equal to 4. Okay? And this is where we would use the same sort of a situation here. We're going to sum them up, though. Okay? And I believe you're going to sum up and subtract it from 1. Subtract 1 from it. Nope, CDF. So what we're going to do here is the geometric CDF. Okay. Of 0.54. And we'll get this number right here, 0.9375. The last one was, what's the probability the firstborn child is at least the 3rd child, firstborn son is at least the 3rd child? That'd be greater than or equal to 3. That's where you take 1 minus that CDF, and that's where you're going to get this number right here. Okay? All of these are very easy to do, okay? Like that last one. If I do 1 minus second distribution, and it's a CDF, it's that F right there. And we've got a 0.5 as our individual success probability, and there's going to be at least the 3rd one. We put a 3 in there. Oops, I'm sorry, 4 children. You put a 4 in there, and you hit enter, and it gives you that 0.625.
I thought it was okay because there was still a couple of little fridge.
Oh, you know what? It's 2. Why is it a 2 here? Because it's greater than or equal to 3. So you got to include. So you do it at 2 so that you get everything that's greater than or equal to 3. I'm sorry. Didn't even look at what I had done there. Sorry. 1 minus second distribution. Just to show you that it gives me that right answer. 2. And that's what we would get, 0.25. So that's telling you that 25% of the time, the 3rd child, at least the 3rd child, is going to be a boy. Okay? That means 1, 2, or 3. That means that allows for a first child daughter, a second child daughter, and a 3rd child son, or a first child son, and the other 2 daughters or other 2 children. Other 2 children don't make any difference in that situation. Or a first child daughter and a second child son. At least the 3rd one, done before the 3rd time. Okay, sorry, stop, take a drink of coffee so that I can keep going here. Okay, so here's another problem. A real estate agent shows a house to a prospective buyer. The probability the house will be sold to that person is 35%. So that's P is going to be 0.35, and 1 minus P is going to be 0.65. What's the probability the agent will sell the house to the 3rd person she shows it to? Well, you know what? This is going to be the probability of x equaling 3 is going to be equal to 0.35 raised to the 2nd power times, 0.65 raised to the 2nd power times 0.35. Okay? Or if you want to do this on the using the calculator, using the geometric functions, it's going to be the geometric probability. It's going to be a 0.353. Okay? And so if we pull up a calculator here, and we do the distribution, and it's a geometric PDF, and it's 0.35, enter 3, and what do we get? 14.8. Okay? And that second question there is how many prospective buyers does she have to show it to? Well, the way you figure that is you first of all find the mean. Okay? So that's going to be 1 over the 0.35. So you take 1 over the 0.35, and that tells you it's going to be the mean number of buyers she's going to show it to is 2.86 buyers. You find the standard deviation, that'd be 1 minus 0.35 divided by 0.35 squared, and that gives you a standard deviation of 2.304 buyers. So how many buyers would she expect to show it to? Well, the mean is going to be 2.863, okay, with a standard deviation of 2, meaning between 1 and 5 buyers. That's going to get 80% of it right there. So let's move forward. No secret word, sorry. Slide sneaks in there on me. I do appreciate the fact that you guys do tell me you're in pre-cal. I'm sorry, that you're in AP statistics. It helps. It really does help. You just don't know how much it helps. And I will look forward to talking to you next course or next lesson. Thank you.